Okay, everybody, welcome back to the Business Exchange, the show where we dive into ideas, people, and innovations shaping the industries of tomorrow. I'm your host, Joseph, and today we have a truly fascinating guest, a scientist, innovator, a deep tech founder who is bringing cutting edge terahertz technology out of the lab and into real industrial use. I'm thrilled to welcome Mariia. She's the co-founder and CEO of Track, a Montreal-based company delivering real-time AI-assisted process control for printed and additive electronics. Mariia completed her PhD in 2021, focusing on photonics and resonate structures for industrial quality control. And today she's turning the research into commercial solutions that help manufacturers reduce weight, increase speed, and scale more sustainably. Mariia, thank you for joining the show.
Thank you for inviting. I'm very excited to be here.
Good. That's great. Okay, so let's just, Mariia, let's start at the beginning. You have a deep scientific background, and your work in terahertz technology is highly specialized. What initially inspired your journey into photonics and electrical engineering?
So it started back in the days when I was just looking what I can do during my undergrad. Just a remark, I'm from Russia. Is it okay to say about it?
Oh, yeah.
Okay. So I was doing my undergrad in the Moscow Institute of Physics and Technology, and I was wondering what I would like to do. And at that time, I had a great connection with Fiber Optics Research Center. This is start there. I was doing spectroscopy there, and I found it very interesting, finding like different properties of new materials, new glasses, new fibers. And then I knew that I would like to do PhD, and I was looking for opportunities to do PhD somewhere. And I arrived to Canada, to Montreal, and I was wondering about spectroscopy more, just change frequency range. So before I was doing infrared and UVB spectroscopy, so ultraviolet visible light. And for my PhD, I moved a little bit in the spectrum, and I arrived at terahertz regime. And I was just passionate about how these lights work.
Oh, excellent. Very nice. So you transitioned from academia into entrepreneurship, often a tough and imitating jump. What was the aha moment that made you say this research needs to become a real world company?
During my PhD, we were producing samples at the Institute for Graphic Communication Printability in Montreal. It's a technology transfer center, so they produce in mass, like huge volume of samples, and I was fascinated how this machine is working. But when I've seen how people are doing quality control, like it's literally someone with a multimeter standing next to the line and trying to extract some properties, I was like, that's not making sense. That it didn't click in my head how this fascinating manufacturing technology and quality control don't follow each other. And at that moment, I was thinking that, oh, my research can be actually solving some problem. It's not just publishing articles, just doing PhD. It can be much bigger than that. And at that moment, I remember that I was like, okay, maybe one day it can happen, that my scientific results will bring the solution for the industrial needs.
Oh, beautiful. Good. So, for listeners who may not know Track yet, how do you describe your mission, and what is Track ultimately trying to solve for manufacturers?
So, as I mentioned, this is how quality control works in many cases today. And our mission is to change this paradigm of quality control being manual with AI-driven inline real-time quality control. So we are printing quality control structures on the side of the main printed device and inspect it with terahertz light. And by looking at the response of the terahertz light, we can judge about what's actually happening on the production line. And our mission actually to really become a hub for the quality control in this industry and being able to make it more sustainable, more efficient, the production, reduce the waste in terms of money, in terms of CO2 emission, and bring flexible devices in our hands as soon as possible.
Oh, very good, very good. So, in your early days forming the company, what surprised you the most about the shift from researcher to CEO?
So there are many things, and I still think that I'm stronger researcher than CEO. First of all, in academia, we tend to prove the idea before making it publishing or like talking about the results. While in the business, you just need to start doing it, like and try to do as many possible pilots, contracts with potential clients, etc. So it's really speed with which we're working. And what was surprising the most to me that having a solution which is working is not, it doesn't mean that it's going to be commercialized tomorrow. The commercialization, it takes really long time and it's very difficult process, which we often underestimate in academia, I would say.
Right, right. So, in looking back, what achievement from the early stages are you most proud of?
I'm proud that we were the first one showing the industrial, like inline quality control for the industrial needs of printable electronics. And we have shown the electrical properties in life, basically, while the manufacturing process was happening. That's, I think, biggest achievement so far we have.
Excellent, good. Well, let's get into the technology and the market you serve. So, terahertz quality control is something most people have never heard of. Can you give us a sample, high level explanation of how your solution works and what makes it unique?
So let's start maybe with terahertz light. Should we introduce people about it or?
Yeah, whichever. Yeah, yeah.
Okay. So terahertz light is basically the light which is located in terahertz range, which we usually define between 0.1 to 10 terahertz. And it has a lot of fascinating properties such as sensitivity to the free carriers. That's why we can do electrical performance characterization. Additionally to that, it's very low energy light, and if you imagine that, it's all the objects for terahertz light are pretty much transparent except obviously metal. And this light has been can be potentially used in many applications such as security in the airport, because it can see through the fabric, so it's easy to find any hazard materials. It can be used even for the medical applications to find, I believe there are people doing some cancer research on that. Like there are beautiful images if you want to compare how X-ray sees cavities in the teeth. Terahertz also can do that and actually can prevent them because it's sensitive to the water, it can see it early on. We talk a lot about 6G communication. It's also fallen in the terahertz regime. And terahertz has been used for the imaging a lot for potentially quality control as well. So, for example, if you have integrated circuits, if there are some miss of the lines, etc., done that, no, if there are some lines missing in integrated circuits, basically they are not functional. But again, with visible camera is impossible to see because you need to look through the plastic to see what's happening under it. And spectroscopy is one of the biggest applications. For example, it's already, I think, being pilot for characterizing and measuring the thickness of the paint on the cars. One of the applications. And in our case, the idea is a bit very different. In our case, the idea is very different. So, since the printing is going at the speed 50 meters per minute, you can imagine how fast it goes. It's basically the same machine I use for printing of newspapers I use for printing electronics today. Just instead of color ink, you print functional ink. And if you look back at the color ink printing, there are always small circles, squares, which are printed. Look at the food packaging at home today. They're done in order to verify the quality of the colors being printed. In our case, we print quality control structure, which are made in the shape of tiny resonators, and we extract the properties of these resonators, and we can say what's happening with ink deposition, how good electrical performance of that, etc. So we look at the reflection from these tiny resonators, and we can judge about what's happening with the production line. Similarly as we do for the graphic printing. So, and by knowing what is happening with the reflection of terahertz light, looking at this behavior, we can predict what's a problem in the production line, and we can avoid them.
Good. All right. So one of the big values of track. Oh, sorry, I don't know. Of track is real-time inline inspection. Why is speed and immediacy so critical in printed and additive electronics manufacturing?
This is the whole idea that we want to do electronics in higher volume and cost efficient way. Cost
Right.
effective, I think is better way, right? Better word. Cost effective, cost efficient. How would you say?
Yes. Sounds good.
So, okay, we want to do electronics in additive way. So we use only the materials which is needed and cost efficient. So in this way, we want to do something in mass production at
Right.
higher volume, and it can be achieved with the higher speed of the production, basically. And why we also need the speed, it's there are a lot of work done on the printed electronic side, that ink is not drying, it's very well deposited,
Right.
etc., 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 to achieve correct performance of the electrical devices. This is the most important.
Right. Yes, that makes perfect sense. What industries or product categories are adopting your solution fastest?
That's a difficult question to answer.
Okay, no, that's okay. If you don't want to, we can move on.
Well, I could say that it's potentially could be applied for IoT production, all IoT devices, and it's including like medical, some batteries, solar panels, RFID tags, and many more. So in our case, we are not limited of the design of the device which will be printed. We just can be integrated on any production line with our quality control structures, and we can inspect the quality of the line while the manufacturing is happening.
Excellent. Yeah, that's great. So when you talk to manufacturers, what are the biggest pain points they face with current quality control methods?
That's manual, so obviously if we print at high speed as 50 meter per minute, it's almost impossible by a human being to check it while the printing is happening. It will be always happening after the printing is completed. And often for assembling the devices made from the made of flexible substrates, the quality control done after the full assembly. So many of these lines being printed has some issues that final device is not functioning, and in this case 6 printed layers has to be thrown into the trash.
Right. Right. Huh. Okay, so adoption of new industrial tech can be slow. What hesitations do you hear from potential customers, and how have you overcome them?
To change status quo is one of the biggest problem, I would say, is the biggest challenge in the manufacturing or landscape overall. So this is the biggest challenge which we have right now, is to change the status quo. And we change it by showing the ability of our solution to do the quality control, which will simplify the life of employees, and on different scale, either it's printer operator or general manager, who will have all information about the manufacturing process in their hands.
Gotcha. Good. So, and how global is the demand? Are you seeing more traction in North America, Europe, or Asia?
I would say Europe is much more advanced at this point than North America, and I believe that with track we can change this and make North America ahead of other others. I don't know, ahead of other locations.
Yes, perfect. And looking ahead 12 to 24 months, what do you see as the biggest white space opportunity for track or for terahertz more broadly?
For track, we will be focusing on the printed and flexible electronics field for this moment, and I believe we will be implemented in more and more production lines. And if you're talking about terahertz light overall, I believe there are a lot of opportunities will come soon, especially with communications being developed. Hopefully soon we will have 6G in our pockets, in our cell phones, and many more.
Gotcha. Good. So every startup has pain points, but deep tech startups often face even bigger ones. What have been your biggest challenges for the scaling of track?
Money raising, I believe it's the answer for many startups would be. I'm very proud how far we went with the resources we have had. I think raising money for last couple of years has been a very tricky point, but the news will come soon. And recently we have raised $100,000 from Shibut, which is great, and
Oh, excellent.
it will help us to uh, speed up our development and commercialization. And besides that, we are still working on closing our round. And I hope we will have more fruitful conversations coming with investors.
Right.
And it's always, what I find is always that we work and we've been probably focusing a lot on tech development because we are both technical co-founders. But I know that the investor world they want to see more business side and business story behind that. We have been working very hard on that and change it. So I believe it will bring its results soon.
Good. So hardware and industrial integration can be complicated. What parts of the commercial process have been the hardest? Manufacturing your own system, supply chain, installation, or customer onboarding?
I would say customer onboarding. The other two is something that we can work with and we can solve with the knowledge and skills we have. Customer onboarding is something that's completely new if you come from research background, and it takes a lot of time and energy to make it.
Right. Yes. Yes. I do know that lots of companies these days for that part of it is using AI to make things transitional and very easy and monitored and all that good stuff. Yeah. All right. So team building is another challenge, especially combining R&D talent with business and commercialization skills. How are you navigating the balance inside your company?
Um, I would say surround yourself with the right people, and so far I have been pretty lucky. Uh, I would say we're still missing business skills in our team, but we are working on changing it.
Gotcha. Yeah, it's a tough one. And if you've got no, and if you've got good team members, that's half the battle. There is to be able to work together and move as one unit. So as CEO, what currently keeps you up at night? Any worries and stuff about the company?
Right now, I would say how to complete the round and how to start selling. Like maybe how to start selling as soon as possible is more is keeping me awake more than raising money.
Right. Yeah, yeah, yeah. At the end of the day, you got to get those sales in. That keeps everything moving and functioning properly. Perfect. So, if you could remove one major bottleneck overnight, something that slows the company down, what would it be?
I don't have an answer for this question.
Okay. No, no, we'll move on. That's okay. Okay. Well, let's see this. Well, I'll ask one more in this section. As track grows, how do you measure success beyond revenue? What metrics matter most to you? Impact, adoption rate, waste reduction for clients, or technological breakthroughs?
I would say adoption in the field of print electronics, that people know us, and what's people know us, they install our solution in the production lines, in their production lines, and obviously everything else comes with it, such as improvement of the manufacturing, waste reduction, CO2 emission reduction, etc.
Gotcha. Good. Um, yeah, before we wrap up, I want to tap into your wisdom as a founder and a scientist. So, we're almost done. So, what advice would you give a researcher or a PhD student who are considering commercializing their work? And what should they know before taking that leap?
Can I talk about Canadian programs which are could be good for PhD students? Yeah.
Yeah.
So I would strongly suggest to start from lab to market program. As a scientist, I think it's a great start to test your skills, to test your abilities to actually do that. This program really helps to show you what is the difference between business and academic world, which is great. And
Mm-hmm.
after that, it will help you to make decision. Additional to that, I would suggest to talk to IP offices in your university because it's very important. IP question. Talk to your thesis supervisor how much your advisor is happy with the idea about commercialization of the scientific results. And I would suggest strongly to expand your network as early as possible in order to succeed.
Gotcha. Good. No, that's great advice. Thank you very much. All right. So, for manufacturers listening, what should they be thinking about when it comes to future proofing their quality control processes?
Um, I believe in AI, and I believe that AI can really change the industry world. And with predictive maintenance, which can happen, and actually Track provides that, and it can really help to improve manufacturing floor, increase the yield, and reduce the waste. And besides that, which is very important for manufacturer, is the knowledge transfer. It's very well known that people who has been working in the printed industry, they're printing electronics today, many of them, but many of them are ready to take retirement. And having this shift from one person to the other, it's very tricky.
Mm-hmm.
And what is necessary is to keep the knowledge inside of the company
Yes.
and transfer this knowledge between the sites, between the shifts, between people overall. This is one of the important points. And second important point is that not only people on the production floor knows about what's happening with quality control, what's happening with the successful prints, let's call it this way, that also this information transferred to the higher level, to the managers, that they know how quality control affects each dollar in the company.
Yes, and I've always thought it would be nice for people retiring in that from an industry if you could download their brain for all the information they have, because unfortunately, they go away. There's still lots of information in their head that never got downloaded to the company, right? So it's
Correct. Yes.
maybe one day they'll just have
Yeah.
that. Perfect. So you seem very driven by curiosity and innovation. What keeps you motivated? What's the big vision for your next chapter with track?
Commercialization. Just this.
Yeah, yeah. Good, good. And finally, how can people follow your work and learn more about track? How can they reach
You
you?
can go on our website. You can find us on LinkedIn, and please contact us if you're looking for some job. We are very looking for the motivated business people. I'm very open to work with students because I know that students have a lot of very interesting and creative ideas how to improve, like how to improve the development of the company.
Gotcha. Perfect. Good. So, Mariia, this has been an incredible conversation. Thank you for sharing everything about you and the industry and the company. Yeah, for our listeners, if you're motivated, you can follow Mariia, find her online and so forth, and easy find in LinkedIn. So, thank you for your time again, Mariia. And to everybody listening, thank you, and we'll see you next time. Take care.
Thank you for the great conversation.
Yes, you're quite welcome.